Good morning, everyone. My name's Harv Saund. I'm a technical specialist for Fusion 360 here at Autodesk, and today we're going to go ahead and take a look at Fusion 360 for sheet metal, which is a new feature that has been released earlier on this year. So it was released in August, and we're going to go ahead and take a look at how the sheet metal functionality works within Fusion and how we can go ahead and leverage all the aspects of Fusion with our sheet metal design, such as communication, looking at some simulation, looking at some CAM and also some rendering as well. So within the webinar today, what we're going to go ahead and do is just cover off two specific aspects. We're going to go ahead and look at just a quick introduction to what we term here at Autodesk the future of making things. And then we're going to dive into a technical demonstration with Fusion and the sheet metal capability. So the first segment will take about 10 to 15 minutes, and then we'll spend the rest of the time within Fusion and actually looking at sheet metal itself. So just a quick overview of what we term the future of making things. Now, we've visited a lot of our customers, and a lot of our customers work in a very similar way to each other. They start off when looking at product development with a concept phase. So these can be, pardon the expression, but fag packet sketches. They could be very quick concepts, maybe some rudimentary 3D models. They then move this into a more production level design. So this will be more along the lines of adding all the dimensional constraints with the product itself, looking at creating all the drawings, PDFs, bills of materials. And then move this into production. So this could be a mixture of what we term subtractive manufacture, so looking at CNC manufacturing of components, or even going down the process of mainly assemblies and bits and pieces itself. We then move this into selling that product, and then finally operating and retiring that product. Now, with that, we can quickly and easily see that it's a very linear process to the design itself. So it's very structured in its nature, it's very siloed in each of the actual products itself. And we term this here a traditional product lifecycle. And it has what we term a fixed product value, because around the selling, operation, and retire phase, we're having to rethink the concept, design, production phase, because we're having to rethink that next generation of product. Now here at Autodesk, we look at this a little bit differently. So during that concept phase, we have a bit more of a broader reach. So we can go ahead and customize the product a little bit easier to what that customer would like, whether that's color changes or whether that's small changes to the product to suit that customer. We can then go ahead and use virtual teams. They don't have to be in the same geographic location. They could be dispersed around the globe, but we can quickly and easily start to collaborate with them, bringing in ideas from manufacturing, from production, from sales, to quickly and easily start to develop the next generation of product. We can handle flexible manufacture. So not tying ourselves down to the route of subtractive manufacture, but also bringing into account all the 3D printing enhancements that have been happening recently. So having the ability to maybe metal or additive 3D print something and run some final machining toolpaths on that. Moving this into the sales phase, the customer's a little bit more engaged and the product's a little bit more personalized to them because we've customized it at the start. And finally, having the ability to connect that product to IoT and Industry 4, and having the ability to then look at that product, how it's being used in field, to then go ahead and inform the next generation of product, or even start to look at some preventative maintenance. So this gives us what we term product as a service. So we're not just selling our products anymore, we're also selling the services that go with it, with regards to stuff like preventative maintenance and also data capture. And it gives us what we term an increased lifetime value, because what we can do is all of that data that we capture from that product within field, we can start to plug back into our design at an earlier stage in the process, giving us the future of making things. Now with that, all of this sits on what we term the product innovation platform. We can start to work with those design silos. So starting to look at concept design, we can then go ahead and move this into production, start to look at PCB design, how we can then push that into mechanical CAD instead of leaving that within ECAD. Having the ability to virtually test something, moving this into the make space and actually create that product. And then finally, the use phase and connecting that product up to IoT and Industry 4 to quickly and easily go ahead and start to inform that design decision a little bit sooner. From here, what we can then go ahead and do is start to build on that. So bringing in those collaborative teams during the design process to quickly and easy start to get that very quick and easy or a broader reach, so we can go ahead and have a detailed manufacturing process further down. We can again bridge that gap, like I said earlier on, with additive and subtractive, having the ability to quickly and easily use that bridge between 3D printing as well as our standard techniques such as subtractive manufacture. And looking at IoT, not just analyzing the product while it's out in field, but also analyzing how the product's being manufactured while it's still with us, and starting to look at machine utilization and how we can then go ahead and make sure that we're getting the kind of throughput that we need from our production floor. So giving us a really detailed platform of products that we can go ahead and start to look at generating this next generation of product. And this is what we term an integrated product development platform. So a single platform to take our design from concept through to production. What I like to term art to part. And you'll hear me use that often within the webinar itself. So we start off with form, so we can quickly and easily start to generate those concept models, move this into functions, start to create those production level designs that we need, 2D drawings, check for fit, form and function. Move this into fabrication, so obviously manufacturing the product, and finally managing that and making sure that all the versions and bits and pieces are captured as we go. So if you want to find out a bit more about Fusion 360 and what we're doing with the future of making things, you can see this on our social media. You've got the Twitter, Facebook, and LinkedIn handles down at the bottom, or you can do a Google search as well, which is what I like to do normally. Now, just a bit of background on why we built Fusion. Now, we went out to our customer base in the actual market and said, okay, what do engineers and designers want from that next generation or next level of CAD tool that they're going to be using? One of the key things that we found was that they wanted access anywhere. Now, traditional CAD ties you down to a specific set of hardware, and you're tied to that machine, maybe in your office or even a laptop. Now, instead of that, Fusion 360 works on Mac as well. So you don't actually have a device that you need to actually or a set of hardware specs that you really need to tie yourself down to. So from here, we can run Fusion 360 on a Mac as well as a mobile device as well, and we have the ability to work anywhere and at any time. Fusion is what we term hybrid cloud, so we can quickly and easily go ahead and access our data wherever we are within the world, and we don't actually need our laptop with us to do that. We can quickly and easily start to view and start to look at how that data is moving on within our design teams. They also wanted us to have a bit more of a connection with different teams. Now, generally what we saw is our design teams are kind of siloed, and then when we move it into manufacture, some design changes need to happen, and it's generally either a set of notes, a piece of paper, or someone knocking on a designer's shoulder to say, look, these changes need to happen because of manufacture. So instead of that, what we have is a next generation of collaboration tools directly built within Fusion itself and this product innovation platform. And we'll be showing you that within the webinar, so we can quickly and easily start to bring teams in from different geographic locations or even different areas within the business to then start to develop that next generation of product and make sure that we've got the correct kind of manufacturing methods that we need within the design itself. So that's the reason, two of the key reasons why we built Fusion 360. Gives us what we term an integrated platform, which we'll be showing you in a second. Gives us the ability to connect a whole host of virtual teams within Fusion or within the business, and also gives us accessibility anywhere where we are within the world. So it gives us that complete 3D CAD that we need when we need it on demand. So let's jump into the technical demonstration of Fusion. Now we're going to go ahead and concentrate this technical demonstration on the new functionality, which is sheet metal, which was released on August 8th this year. And we're going to go ahead and focus in on some key areas. Now we're going to look at this router table, and in specific, we're going to go ahead and look at the actual router head. And we're going to go ahead and create the sheet metal components for this segment itself. So these areas just here, so the cap at the top, this front sheet metal component, and this one at the bottom as well. And we're going to go ahead and look at this in how we can use this within Fusion itself. So we're going to go ahead and initially look at the sheet metal functionality, how we go ahead and develop a sheet metal component within Fusion, some of the sheet metal tools within Fusion. We'll look at some of the rules, how we can go ahead and override those, creating flanges and bits and pieces. We'll then move this into what I mentioned before, which is our communication layer, how we can communicate this design out to other people within the actual organization. We'll then look at how we can take that design and use some of the simulation tools within Fusion to quickly and easily test the design and make sure that it is fit for purpose before we manufacture. We'll go ahead and start to look at the flat pattern and the actual drawing and creating the bend table within Fusion as well. So again, a real quick and easy way of doing that. We'll move this into the render space. So again, we want to create a nice visual for our customer, and we'll go ahead and do that. And then finally, we're going to finish up with the CAM. So we're going to go ahead and look at how we can manufacture that product. So in effect, what we're going to go ahead and do is take a design from art to part. So it gives us that complete area that we can then go ahead and loop through. And again, I'll be going back and forth and switching between Fusion just here. If there are any questions during the webinar, there is a question tool within the actual webinar itself. You can raise those questions and either I'll get back to you at the end of the webinar, or if we don't have time, I'll get back to you after the webinar itself. So let's jump in and let's go ahead and take a look. Now, the first thing that we're going to go ahead and look at, like I mentioned, is actually creating the sheet metal components within Fusion. And we're going to go ahead and look at the sheet metal workspace, how we can use sketches to create the sheet metal components, adding flanges, looking at how we can create cutouts, and looking at how we can unfold, fold different faces, looking at how we can monitor edges and change the kind of shape that we need from an edge as well. So let's jump into Fusion and let's go ahead and take a look. So here's my example, or here's the router head that we're going to go ahead and use. And we're going to, like I said, create all the enclosures and bits and pieces for this design. Now, at the moment, I'm in my modeling workspace, as you can see in the top left-hand corner of the screen. And if we want to jump into sheet metal, it's just simply a workspace switch. So we can quickly jump into the sheet metal environment, and we now have sheet metal specific tools. We start off with our sketches on the left. We then have the option to create new components and flanges. We have the ability to look at sheet metal rules. And if I expand each of these, you'll see specific sheet metal tools as well, such as unfold, and also the option to create a flat pattern as well. So I'm going to go ahead and start off. I've already created a quick sub-assembly for our sheet metal covers just here. Now, there's a reason why I've done this, and I'll show you later on as to why we've gone ahead and done this approach itself. But first thing I'm going to go ahead and do is create a sheet metal component. You don't have to do this. You can just start off with a sketch. But I like to organize my browser on the left-hand side of the screen, so that's one of the reasons why I'm going to go ahead and do this. So I'm going to call this upper cover. And at this stage, I can start to specify the sheet metal rules that I want to use. Now, we have a standard library of rules that we can go ahead and work with, or we can go ahead and have a couple of customized rules as well. And each of these will then go ahead and start to look at specifying your thicknesses, K factors, bend allowances, conditions for the bend, looking at relief statuses and bits and pieces as well. So I can set these just here. So I'm going to set that for this design. But if I want to modify any of those, I go up to my sheet metal rules. And from there, we can start to see steel, aluminium, we have a library, and then you have the option to edit or even create a brand spanking new rule just there. So you can set this to the machines that you guys are using. So again, if you're going to be using specific press brakes, you can go ahead and work with those with the tooling that you've got for those press brakes. So for this design, I'm going to go ahead and start off with a sketch. So I've already created a few sketches itself that I'm going to go ahead and use, and I'm going to just snap to a top view so you can see the sketch that I've created. So this is the sketch that I've created just here, and it's just a couple of offsets from a couple of edges from the design so that we can then go ahead and capture the absolute outside limits of that design. So using this sketch, we're going to go ahead and quickly create that first sheet metal component. And we have a single flange tool to do that. Now, our flange tool will go ahead and start to look at creating base flanges, contour flanges, open flanges, edge flanges, so on and so forth. So if I pick up on our flange tool, specify a contour or a sketch edge, you'll notice that it's open, so you don't actually need to have a closed contour to create the first flange itself. You can quickly and easily, very visually, start to grab and drag and start to create the flange that you want to go ahead and use. Now I want to snap to a specific height because this flange is going to finish at this face just here. So as you can see, as soon as I hover over it, will then go ahead and give me a size that I'm going to snap to. So I'll snap to that. And I can also go ahead and set a value for this. So I'm going to go ahead and call this -12.5. And from there, I've hit enter, and we can go ahead and start to see that flange being created. I can come back here, edit the feature, and we can start to specify some extra options. You can also do this when you go ahead and create the flange. I was just a little bit too quick with my enter key, so I press the enter first time round. So let's go ahead and start to set a couple of options for this. Now at the moment, the sketch itself is sitting on the inside, and our flange is sitting on the outside. Now I actually want the flange to sit on the inside of that sketch. So over on the right hand side of the screen, I can specify my thickness direction. So whether this is on one side, whether this is flicks to the other side, or whether this is symmetric, so the sketch sits in the center of the actual flange itself. That's totally up to you how you want to go ahead and do that. I'm going to go for the other side so it sits flush with the actual components itself. And then at this stage in our dialog box, we have the option to go ahead and override the bend radiuses as well. And again, we have the option for extrusions and bits and pieces. So it gives us the ability to very quickly and easily start to specify that first flange that's being created within Fusion. So great, we've already started to create that sheet metal component. Now, one of the key things that I want to go ahead and do here is take this component and make it a little bit more complex than it actually is. So from here, I want to grab a flange on this edge and bring them in. And as you can see, we've got a slope on this side at the back just here. So I want to kind of match that slope and create a flange that's just in this top section just here. So again, I'm going to go back into that flange tool. And if I right click, I have my flange tool on my gestures menu. And from there, I can pick up a couple of edges just here and here. And with that, I can just grab the arrow and drag. Now I like to do things visually, and as you can see with Fusion, you can do it very visually. So very quickly and easy, you can start to create those flanges. Now they're going the wrong way. I want to flip them. I have two options. On the right hand side of the screen, I have the flip option, so I can flip that the other way, or I have the rotation ring that I can use. Now this is very useful, and I use this more than I use the flip option, because I can actually visually see if I want an angle on that design. Very quickly and easily, it gives us a very easy and visual way of actually utilizing that. A great tool just there for Fusion. Now again, I can go ahead and start to specify the overall distances that I want. Now I want this flange to be 4 inches, and from here I can start to specify our bend positions, so whether it's inside or outside. We can start to specify a height datum as well, so where we're measuring that flange from. So at the moment it's set from outer faces, so it's going to measure it from this face just here to the edge. If I wanted it inner faces, it will measure it from the inside edge to the outside edge itself. So it gives us the ability to quickly and easily start to limit those and change those as we need to. So if I snap to a back view just here, as you can see, the flange finishes just short of that top pillar just there, but it is actually a full length flange. Now in traditional CAD, to change that flange, we'd start to look at maybe adjusting sketches, or even coming back in here and starting to create smaller cutouts, and maybe actually the flat pattern may start to fail. We'd have to start to create potential relief cuts in certain areas. With Fusion, we've kind of changed the game with this. On the right hand side of the screen within our dialog box, we actually have every flange is considered its own. So from here, we can actually adjust the overall parameters for the flange, so the size of the flange individually from each other. So for edge 2, which is that one that I've got selected just there, I can go ahead and say that's either going to be a full edge, or I can make that symmetric. So if I grab one of those arrows just there, you'll notice I can extend past the extent of the flange, and the relief options appear as they should do, or I can come back in, and again those relief options appear as they should do. So very quickly we can have that symmetric flange either side from the center. If I wanted that to be maybe two-sided, so an offset, so one side's longer than the other, or even if we wanted an offset where the one side overlaps the edge of the flange and the other side is actually centered or inside that, we can go ahead and do that very simply within Fusion. Again, I'm using the arrows on screen. You do have dimensional control as well. Or we can go all the way and say that flange is going to be slightly longer. And we also have the option for 2 offsets. So you can specify a reference edge or a point that you want to use, and you can specify where that flange is going to be within that point. So I'm going to go back to a full edge just here, and maybe what I want to go ahead and do is use two sides. I can actually go ahead and bring this side down because that's going to be flat to there. And what I want to do is just bring this side back up again. So for that, I'm going to go ahead and make that -2 inches from the center. And that's then going to go ahead and create me a flange that is slightly off from the edge or the end of that slope, and also put the correct relief cut that I need in. When we go to flat, it will be correct for that. Now you'll notice that's actually only occurred on the left hand side of the flange, or the left flange that we've created. We have complete control like I mentioned on the other one, so I can quickly and easily go ahead and specify this flange may be slightly different. So it gives us a very quick and easy way of actually creating two flanges within the design that are different to each other. So again, traditional CAD, it would be very difficult to do, or could be quite tricky with a lot of steps to do. Now I want to create that slope, so we can come back in here and we can start to use our sketching tools. So I'm just going to pick up on my line tool just here. We'll make sure that we pick up on the correct point that I want to use, which would be that one there. And very simply, we're just going to go ahead and draw out just the relative shape that we want to go ahead and use to then create that cut. And again, using press pull, I can quickly and easily create that cut that I need from our sheet metal component, and just specifying that I only want to cut the upper cover, which is the component that we've done, and it's created that flange for us in the correct form. Now, one of the cool tools within Fusion that gives me the ability to start to look at individual areas of the sheet metal component, or individual bends, is the ability to go ahead and use our tool called Unfold. This will allow me to quickly and easily pick a stationary entity, which would be that one just there, let's say, and we can then go ahead and unfold individual bends from that. If I pick this as a stationary entity and pick that one, it will then go ahead and start to unfold each of those bends itself. And we can unfold multiple bends if we wanted to, and we can start to see how that design starts to develop within the flat. A very nice tool to quickly and easily start to analyze how that sheet metal component is going to be built if we need it. Now, using that unfold tool, I want to create a quick cutout on the front, because the cutout on the front is going to be done within the flat. So it gives us the ability, using this unfold tool, to specify a stationary entity, unfold all the bends, and very quickly and easily we have all of that component completely flat. And from here we can quickly and easily start to create a cutout that's going to go ahead and be a detail feature on our design. And again, I just want to make sure that I am cutting just the upper cover, and it gives us that just there. Now when we refold, which is this tool at the top just here, this is then going to go ahead and give us all the correct fold parameters when we go ahead and look at the development over the flat. So instead of us going ahead and creating a cutout within the 3D, we can do it within the 2D, which is where this would occur, and then we can go ahead and see what the development will be. So a great tool just there with fold and unfold. Now we want to go ahead and create a few more flanges, just one on the back just here, and then a couple along the top. So again, just let's pop back into our flange tool again. We'll pick up on those two edges just here and here. And again, we have the ability to just very quickly go ahead and create just those flanges that we need. So this one, I'm going to go ahead and make about an inch wide. Actually, just go ahead and make that 1.5 inches, because it makes it look a little bit better. And if I just again snap to a top view, we're going to go ahead and quickly start to see where these flanges are. Now these flanges actually match up with this edge, but we've actually got a block in place. So what I'm going to go ahead and do is maybe move those outside to that bend. So what that will then go ahead and allow us to do is actually match that face up to this inside face itself. So when we come out of the component and activate a higher component, you go ahead and start to see that. So very quickly we've created that one. Now we also want to go ahead and create some tabs along the top. So again, I'm just going to go ahead and pick up on a few of these edges itself. Let's just go ahead and pick those again, because I've done those in a different way. Let's go for the inside edge instead. You can just reselect from the dialog box if you wanted to. I'm just lazy, and I'm going to go ahead and reselect the ones that I want. So let's go for these just here. And we'll pick up on all these internal edges. There we go. So again, one of the cool things with this flange tool that we've got within Fusion, I've picked all of those edges. Now in traditional CAD, again, it would be quite tricky to go ahead and start to create all those miters within the design. Fusion goes ahead and does that automatically for us. So if I go ahead and make those flanges, let's say an inch wide or an inch in thickness, it will go ahead and do that. All of the miters for us, as you can see just here. And again, what we can then go ahead and start to specify is the ability to then specify where that flange would sit. Now we're going to have a top cover, and as you can see, that's my back panel just there. So I can quickly and easily flick these to inside, and then that's the top section where my cover is going to go ahead and sit. So very simply, very visually, we can go ahead and create sheet metal components within Fusion itself. And very simply, that's that first component done. Now, what I want to go ahead and do is maybe create a flat pattern at this stage, just to go ahead and check that design. So I can pick a stationary face, and very quickly the flat pattern is created. Now within that flat pattern, we can go ahead and start to see all the bend lines and bits and pieces within that design. Now I'm going to be using this flat pattern in two forms a little bit later on. So we're going to go ahead and look at this in the drawing environment and bend tables, and we'll also go ahead and look at this in CAM. But I'm going to leave this as it is for now. So if I exit the flat, we're back just here. And if I want to activate that flat at any time, I can find that flat within the browser, and we have the option to activate at this stage, and it will go ahead and take us back to that flat pattern. Now, we're going to develop this design further because we want the top cover and we also want the one below it. So let's go ahead and create a couple more components. So from here, I want to go ahead and specify maybe our sheet metal covers as our top level, and I want this to be top cover. And we'll go ahead and keep those same rules. Now I'm going to use, again, I've got a sketch that I want to go ahead and use. Now this one is a closed contour. And again, we can quickly use closed contour sketches to quickly and easy go ahead and create the overall design itself. So I want that one just there. There we go. Our profile selected. And very simply, we can create that sheet metal component, and it will add the thickness where we need it to be. Now that's a very simple sheet metal component, but it is still a sheet metal component that we're going to go ahead and work with. And then finally, what I want to go ahead and do is create the lower section as well. So again, I'm going to create another component. So I'm going to go ahead and call this lower cover. And again, specifying some sheet metal rules. If they're going to be different for this component, we can go ahead and have them different. And again, I've got some sketches that I want to go ahead and use. So I've got a lower sketch just here that we're going to go ahead and work with. And again, just using that flange tool, we can quickly pick up on that sketch. And again, we can drag that up. So this one itself is actually going to be 11 inches tall. So again, it covers the actual design itself. And this router is currently at its lower position. Now again, what I can see is I've hit the OK. Again, I'm very quick with my mouse, but the actual covers overlap. So I can always come back into my timeline at the bottom, edit that feature, and we can start to go ahead and start specify where thicknesses and bits and pieces occur. So that works exactly like any other feature within Fusion itself to go ahead and do that. Now from here, we want to go ahead and develop this design a little bit further as well. So what we're going to do is add a few flanges to our design. So again, I'm just picking up on a couple of edges that I want to use. And I want that one, small one just there, and maybe this small one just here. And again, I can go ahead and move those out, but I also want to go ahead and put a bit of a tilt on these instead. So I want these to be at a specific angle, so they just taper in slightly. And what I've done is I've missed an edge. Not a problem. Over on the right hand side of the screen, we just hit the little plus icon or hold down Control on your keyboard, and that will then go ahead and create that edge for you. And again, you can start to specify those distances. So I'm going to go ahead and make that minus 40 degrees, so it makes it very nice and or a very nice finish to that design. And again, at any option or any time, we can start to override any of the rules for those flanges. So if there's specific relief options you want for this flange, you can go ahead and specify those. You can start to specify your bend overrides, so what your bend radiuses are going to be, your 2 bend corner overrides, and your 3 bends as well. So once that flange is created, great, our design's done, but we also need a slight little detail on this design as well. So again, coming back into that unfold command, we'll quickly and easily unfold that design. And again, just using a predefined sketch that I've created, we'll quickly and easily go ahead and create a cutout for this design as well. And again, I only want to cut the lower cover, and very quickly and easily that's done as well. We'll refold, and then when we go ahead and fold this design or create the flat for this design, specifying that stationary face, you can start to see that that flat's created as well. So very quickly and easy, we can start to develop different levels of sheet metal component within Fusion itself. And if I just go ahead and activate our top level design itself, so let's go for our sheet metal covers just there. Our sheet metal cover designs are done. So very simply, using that single flange tool, we've been able to go ahead and create a whole host of different flanges within Fusion, also create a whole host of different flat patterns within Fusion, and have the ability to quickly and easily start to develop a whole host of different designs directly within Fusion. So our Z-axis covers are actually done very simply within Fusion itself. So it gives us the ability with sheet metal within Fusion, a quick workspace switch. We can pick up on open or even close contours to quickly and easily start to drag those contours, creating the kind of flanges that we need. We start to specify the type of edge conditions for those flanges, having the ability to quickly and easily go ahead and specify different edge conditions. So whether the flange extends past the actual edge of the actual flange that you're creating, or even going ahead and looking at having them symmetric on bits and pieces, we can go ahead and angle those flanges very visually within Fusion, and we can quickly and easily start to specify any bend positions, datums for heights, and also all the rules that we need to then go ahead and manufacture the design itself. So moving on a little, we may want to go ahead and start to look at communicating that design with someone. So we may want to go ahead and start to look at how we can open this up to the broader team and start to look at how we can communicate the manufacturing methods or even the flat patterns directly to someone else within the actual business itself. So let's jump back into Fusion. Let's go ahead and take a look. Now within Fusion itself, down at the bottom left hand side of the screen, we have a comments tab. So from here we can start to look at creating in CAD collaboration with whoever we need. So from here I can go ahead and start to specify just a very basic comment, or we can go ahead and start to specify comments on a specific object, or even going ahead and commenting on a specific point. So if I go ahead and comment on a specific point just here, so we can say sheet metal cover's done. What do you think? And if we post that, this is then going to go ahead and post a comment for us, having the ability to quickly and easily start to pull in different teams and collaborate with different people within the business itself. So this is just uploading at the moment, and it's going to go ahead and take a snapshot of the image that we've created. It will upload it, and then from there we're going to go ahead and start to look at how we can view that comment and how we can start to engage other people within the design process. So we have that comment that's uploaded. So let's go ahead and open this design up within a web browser. Now, one of the key things for us with Fusion itself is that we don't actually have an install for viewing designs. So you don't actually have to go ahead and install anything to view it. It's all there ready for you to do within a web browser or even a mobile app. So if I pop back a little level just here, I can go ahead and start to see all of the options just here for all the parts that we've got. We can start to see who the owner for those parts are. We can see who's actually using that component itself. So if I go back into that Z-axis assembly, I can see all the parts that are being used within that component. I can see what that design's used in and any drawings that are created for it. We can see that comment that I've made on the right hand side of the screen, and we also have the option just here to share this design with anyone. So from here we can quickly and easily start to give someone access and a link to go ahead and start to share that design. So it gives us the ability to choose who we go ahead and share this with. So I can see the comment on the right hand side of the screen. It's just preparing that for viewing at the moment. My internet is looking to be very slow today, or a little bit slow. There we go. So we have the option for sharing. So again, I have that little link just there that I can copy. We can go ahead and add a password to this design if I needed to, or I can set emails or even embed this within a web browser. But if I hit the view tab, this is then going to go ahead and start opening up our view tool. One of the key things with Fusion is that we have all of our versions as well along the top. So I've actually developed this design to 22 versions. So every version within Fusion is captured. So if you ever need to go back, we have the ability to go ahead and do that. So from here, what I can go ahead and see is the sheet metal cover's done within the actual web browser itself. I can see any comments that are captured. So we can see that directly on screen just there. We can also show that in a feed that you can see just here. And we can start to see what comments are captured at what version. So it gives us the ability to quickly and easily start to capture an audit trail. Now, if I want to comment back on that design, we have the options down at the bottom to do red line markups if I needed to. So if I wanted to go ahead and pick maybe an arrow, we can go ahead and put an arrow in. We can go ahead and put some text in, and we can say, looks good. Can we run a simulation? It's a very vague comment to have, but we'll go ahead and save that. And that will then go ahead and create us a red line markup for this design. So again, sharing this design with anyone that we need, whether that's manufacturing, whether that's outside vendors, whether that's someone, a sheet metal fabricator, all bits and pieces, we can quickly and easily do that via a web browser. No need install anything. So I've created that comment, and as you can see, it's posted on the right hand side of the screen. But if we pop back into Fusion and I come back into this comments tab, it's automatically updated within my Fusion browser as well. So from here, I can quickly and easily start to see that snapshot once that's loaded of that design, and then we can quickly start to see how that design needs to develop using our communication tools within Fusion 360. So again, opening up sheet metal design not just to your design department or your manufacturing department, but very simply going ahead and expanding this to the fabricators that you're going to use to create the component, your manufacturing teams off-site, so it gives you a very simple way of quickly and easily collaborating. Like I mentioned, this is web browser based, and we're not tying you down to Chrome like I'm using here. You could use Edge, Safari, whatever web browser that you're working on, and it also is available on a mobile application. So again, you can quickly and easily start to zero in on a mobile app, just in case you're on holiday and you just want to quickly check to make sure that your design team is doing what they should be. You can quickly and easily go ahead and do that just to make sure and make any comments that you need. Now, moving this design along, they wanted to go ahead and run a simulation. So let's quickly look at how we can take that sheet metal design that we've done and go ahead and look at how we can pop this into the simulation environment, and giving us the ability to use that sheet metal design that we've created directly within the actual platform itself. So let's pop back into Fusion. Now I want to go ahead, like I said, and create or test this design. So I may want to go ahead and put a 200 Newton load on this face just here in the opposing, hold it at the top, and start to see what's going to happen when we go ahead and do that. So just like anything within Fusion, it's just a workspace switch. We're not going ahead and activating any add-ons or bits and pieces like that. We can quickly and easily jump into our simulation tools, and from here we can activate a whole host of very high-end simulation tools within Fusion. We have the ability at this stage to do your standard static stresses on assemblies. We have the option to look at frequencies. Now we mentioned PCBs and bits and pieces earlier, so we can start to look at thermal analysis as well. So starting to look at how heat dissipates. But we also have the ability to start to do stuff like generative design at this stage as well, such as shape optimization. So we're going to go ahead and focus in on static stress just here. And if I click OK, this is going to go ahead and start our static stress study for us. Now, I don't need to go ahead and analyze everything. I just want to analyze this top cover or the upper cover and the top cover. So I'm just going to double click and select those two just there. And what we'll do is we'll suppress everything else out of the design. And I've just used the right click to do that. So here's our design. Now what I want to go ahead and do is put a load to this, or set the materials initially. So along the top, we start from left and we go right. So at this stage, we can start to specify the type of material that we want to go ahead and use. So if this is going to be an aluminium, if this is going to be a steel, you can quickly test the variations between the two and compare them. Now I'm going to leave them as they are. We can then go ahead and start to specify some constraints. So now I'm going to fix this at the top face because that's going to be where it's going to be potentially bolted in. This bottom section is going to be a little bit more free, so we can go ahead and start to specify the loading conditions on those. Now the loading conditions can be forces, pressures, they can be moments if you need them to, and I can specify target faces that I want to go ahead and apply those to. And maybe I want to go ahead and apply a 200 Newton load, and that's a total 200 Newton load at the moment on both faces, but if you want it on each face, you can go ahead and put a force per entity. If I click OK, we are analyzing an assembly, so we need to go ahead and just create the contacts, which is the interaction between the two parts itself. So we'll quickly go ahead and do that within Fusion, and that's then just going to join these two together. And then finally, we have the option to solve. Now, before running a solve, we can quickly pre-check, make sure that we've got everything in place. Now, one of the key things with Fusion, I mentioned it earlier, is hybrid cloud. So you have the option to run on cloud. So if you don't have the hardware on your machine, you can take all the simulation solving and chuck it straight up to cloud. This is then going to go ahead and allow you to quickly and easily solve the design on cloud, and this is then going to go ahead and chuck the results back to you. So you don't actually need to run this locally on your machine. If you do have the hardware on your machine, you can run this locally. I do, so I'm going to just quickly run this locally and we'll hit solve. And this is then going to go ahead and run a simulation for us. So what it's actually going to go ahead and do is just quickly mesh the model. So it's going to break this down into small elements. We are working within what we term finite element analysis. And from there, it's then going to go ahead and run the simulation. And then it's going to go ahead and give us some deformed plots at the end of it to see what's going to happen when we fix that top face and we punch two 200 Newton holes either side of the actual design itself. and see if the part's actually going to fail, or if we need to beef it up in specific areas, if we need to add certain ribs or gussets and bits and pieces within that design. It'll take a minute or two to solve, just to quickly and easily finish off, and then from there we'll then go ahead and start to analyze the results and start to see what kind of results we're going to get for this design. We could, again, like I mentioned it earlier on, push this to cloud and then carry on with Infusion and then start to look at how we can develop other areas of the design. And then when we come back, Fusion will then go ahead and give us those results itself, or we can, or at any time pop back and see those results. So it's going to solve for us. It's going to take a minute or two. There we go. And then once we're done, we'll go ahead and start to look at those results. So one of the key things that we get straight away is the minimum safety factor within the design, and we can start to see if that design is strong enough to suit the minimum safety factor. So at the moment, our minimum safety factor is 15, so it's very strong within our design. We can start to look at the strongest areas of the design, and our results detail give us a quick snapshot on what the actual design is going to do. If I start to look at stresses within that design, we can start to see where the maximum and minimum stresses are occurring in that design itself. And we're actually quite good with this design. It's quite strong. We can start to look at displacements. It's only moving about 0.1 of a millimeter. Now, at any point, you can animate these designs. So again, if I play that through, we can start to see that design animate as needs. And again, just like before, we have the ability to quickly and easily start to communicate this design with anyone, and we can start to view these results within a web browser as well. So it makes it very simple and very quick and easy to then start to communicate everything with whoever you need to within the design itself, or whichever department you need to. So very simply, we've been able to go ahead and test that design within Fusion. Taking that design, designing the component as a sheet metal component, pulling that into some communication, someone wanted to run a simulation. We've run that simulation and we can see that that design is actually fit for purpose. It's more than strong enough to actually handle the loading that we're putting onto it. Now, one of the other key things for us with sheet metal components is manufacturing detail. So we need to go ahead and start to look at how we can take that flat pattern that we created earlier, pop it into a drawing and start to create bend tables and bits and pieces such as dimensions and bend annotations from this. So let's jump back into Fusion and let's go ahead and take a look. So back into Fusion just here, what we'll do is we'll jump back into either the model or sheet metal space. It makes no odds at this stage. And we'll start to create a drawing from this design. So let's create a drawing from the design. We can choose either the full assembly to create. So we want to go ahead and create a GA over the whole thing. Or we can specify the components that we want to go ahead and use. So I'm going to just pick this sheet metal cover subassembly. And we can either specify the subassembly or we can specify a specific component within that. So if I just specify our upper cover just here, and from there, we have the option, because we have a flat pattern available to us, to either create the drawing for the folded model or create the drawing for the flat pattern. Now, when we're in the drawing environment, we can do both. So once we go ahead and create the flat pattern drawing, we can specify any drawing templates that we want to go ahead and use, create a new one. If it's a template that we've got existing, we can use that. We can specify the standard we're working in and the overall sheet size. So once we click OK, we're into our drawing environment within Fusion itself. And from here, we can quickly start to create the design itself. So again, I'm creating the flat pattern view. So I actually want to go ahead and make this slightly larger. So let's go ahead and make this maybe 1:4. Make it a little bit bigger. There we go. We'll drop that in place. And again, we have the option to create this shaded. We can specify any edges and tangent edges that we need to. And if we click OK, that's then going to go ahead and drop our flat pattern in. Now, our tables tool now, especially seeing though it's a sheet metal component, will default to a bend table. So if I specify that bend table in place, all of our bend tables automatically generated, and all the number sequences are generated as well. And that bend table goes over into my title block. I want to change that. I'll just grab this arrow down at the bottom. We'll drag this up. We'll specify that the break for that bend table is there. Now, as we can see with this, there's a few numbers that overlap. That's not great. So what we can go ahead and do is just grab that number and drag. And what that's going to go ahead and do for us is quickly and easily go ahead and move that around. So once we move that around, it also automatically goes ahead and puts a leader in for us. So again, we're not having to go ahead and do that manually. We can quickly and easily grab any of those bend notes that we've got on the actual flat view and go ahead and put any of that detail in. And again, from here we have complete control again with dimensions. So again, we can go ahead and create some ordinate dimensions if we wanted to, or we can create some chain dimensions or baselines as we need to. So if I was to create an ordinate, we can quickly and easily start to create the ordinate dimensions that we need in place to then specify where each of these edges or bend edges are going to occur within our design. So it makes it very simple and easy to create a very detailed bend drawing directly from Fusion itself, especially having all the bend tables and bits and pieces in place. And again, for our output, we have the option to go ahead and do DWGs, PDFs, or if you wanted to just output the bend table, we can do that as a .csv as well. So very simply within Fusion, we've been able to take that design from just a standard development or a 3D model development into a flat pattern drawing. So from here we can quickly start to specify all the dimensional information, the bend table information, and very simply have the manufacturing detail that we need to pass on to the shop floor to then manufacture that design itself. So again, giving us a very simple and an easy way of actually going ahead and creating all of that information within Fusion. Now from here we may want to go ahead and communicate this design to a customer, so we need to go ahead and just finish it off and make it look very nice so we can create a render. So again, just using that workspace within Fusion and using the integrated platform, we can pop back to our 3D model and we can jump into our rendering environment. So from our rendering environment, we can quickly and easily start to show someone exactly what this design is going to go ahead and look like. So we can start to specify the appearances that we want to go ahead and use. So if I wanted to go ahead and maybe use a stainless steel, a polished stainless steel, maybe a blue just here, and maybe a rough blue on the top. Maybe I go ahead and use a satin aluminium along the top. We can go ahead and drag and drop those. Now these are the ones that exist in my design already. We also have materials that we can go ahead and use just here as well, that we can go ahead and either download, which will be just clicking on that download link, or we can just drag and drop. So if I wanted a polished brass along the top, we can go ahead and use a polished brass, a very expensive looking cover just there. From there, we can start to specify the scene information. So from here, we can start to specify the environments that we're going to go ahead and work in. So again, if you wanted to put this Z-axis assembly in a crossroads, you can. Or you can just drag and drop some photo booth options just here. So from there, we can start specifying your reflections, any settings for that design. We can go ahead and start to look at the center of focus, where the blur is going to occur. We can save those as default as well. And before we go ahead and render, we have the option to do a quick in-canvas render. This is going to go ahead and create me a very quick preview to show me what that render is actually going to go ahead and look like. And we have a threshold along the top because we're using a tool called ray tracing to do this. So this is going to refine that image until it finds a limit that we've set, and it will then go ahead and make sure that that image is very nice and finished that you can go ahead and work with. And if you wanted to capture just that image, we have the option just there, but we also can quickly and easily pass this off to cloud. So rendering generally takes a lot of resource. So we can chuck all of the resources up to cloud, let the cloud render it, and then this will then go ahead and return us a result that we can then go ahead and use. But if you do have the resource on your machine, you do have the option to local render as well. So it gives you a very quick and easy way of actually choosing what you do at that stage, and again, not needing the specific hardware that you need to render on cloud or render locally. So very simply, we can create those visuals for customers as well, making it a very simple, easy process to jump in from a sheet metal component to create the part, look at creating all the manufacturing data, looking at the simulation, looking at going ahead and communicating it, but also going ahead and looking at giving that customer a nice visual at the end of it. And then finally finishing off. Now we've done all the arty stuff, so actually creating the part, looking at creating all the manufacturing information for that part, looking at how that part's going to join to other components, looking at communicating that design, looking at running a quick simulation or a render. But what we actually want to do is create it. So built within Fusion is integrated CAM tools. So we can take the flat pattern that we've generated and create a laser cut or a water jet cut path that we can go ahead and work with. So let's jump back into Fusion and let's go ahead and take a look at how we do that. So I'm just going to jump back into the modeling environment, and you can see we've pushed those colors back. And let's come back in for our workspace switch just here and go into that CAM environment. Now our CAM environment allows us to go ahead and pick up on flat patterns now. So it gives us the ability to choose the flat pattern that we want to cut. So I'm going to, for this example, just use the upper cover flat pattern. So if I activate that, this is then going to go ahead and activate that flat pattern within the CAM workspace. So from here, I can go ahead and start to specify the setup for that design, but we can see that all the bend lines and bits and pieces are taken into place. We can increase the size of that setup. So if you're going to be doing this on as a nest, we can go ahead and maybe look at creating a whole multiple of these and start to look at nesting them manually. Specifying the origin, all we then need to go ahead and do is just specify the cutting parameters. So under our cutting tools, we can specify the kerf width that we're going to be using. So I'm using a water jet just here. So once a kerf width set, which is 1 millimeter for my design just here, all I need to do is pick up on the contour. So that's the outside edge of the design. We can specify any internal details as well at the same time, and Fusion will then go ahead and put or generate all of the 2D toolpaths that we need. So if I just wind the speed up, specify to play through, we'll just rotate around slightly, and as you can see, it's going to cut all of that information for us. So again, at this stage, we're not actually going ahead and resigning ourselves to pushing this out to someone else to do. We can actually go ahead and generate all that G-code and that toolpath directly within Fusion itself. We have some standard posts that ship within Fusion, so you can quickly and easily go ahead and pick up on the post if it exists within Fusion itself, and then post out. So that's all the G-code taken into account. Or we can go ahead and find that at cam.autodesk.com. So there's a few posts on there that you can go ahead and use as well. So really quickly and easy, we can actually go ahead and take that design from art to part. So what we've gone ahead and looked at is that new functionality, which is sheet metal within Fusion 360, having the ability to quickly and easily create a sheet metal component off of sketches, having the ability to generate flanges and then specify the end conditions for those flanges, having the ability to quickly and easily adjust those, put your standard methods such as sketches in and cut certain areas of those flanges. We can quickly start to look at how we change those rules, how we go ahead and create the flat patterns, unfold a single flange or a single bend, and start to create options just there. We can then move this into the communication environment. So from here, we can start to communicate that design with whoever we need, whether that's manufacturing, whether that's an outside subcontractor. Move this into some simulation. So from there, we can start to look at simulating that design and making it valid prior to us actually manufacturing anything. Moving this into our drawing environment, creating a flat pattern drawing with our bend tables, looking at rendering this for visuals for a client, and then finally looking at actually generating the part from either a laser or a scene or a water jet cut method. So you can quickly and easily start to take that design from, like I mentioned right at the start, art directly through to part. So that's just a very quick intro into our sheet metal tool within Fusion 360. There are a whole host of different other bits and pieces, and you can find those on either our YouTube channel or even within the help menus. So they are there with tutorials itself. Now, just before I end the webinar itself, I just wanted to also focus in on a couple of the previews that have been released within that August release as well. So one of them being ECAD to MCAD integration as well. So this is, again, the August release that has just happened. It's just a very quick ECAD to MCAD environment that we now have within Fusion 360. Now, as we already know, and I mentioned it before, products are changing. So we're starting to put PCBs and bits and pieces into parts. So directly within Fusion now, we can actually go ahead and specify a PCB layout by specifying a sketch. And using our Eagle tool, we can quickly and easily start to specify that board layout, push it from Fusion to Eagle, and then from here, we can then start to specify that overall board layout. Using the 3D libraries, we can then start to build that PCB in 3D, which gives us the ability to quickly and easily start to check for interferences with designs. And then if we need to make any adjustments to the PCB, we can go ahead and make those adjustments live within 3D. We can find those interferences and then pull that design directly from Fusion into Eagle to reset that board, giving us the ability to quickly and easily have a more integrated environment between ECAD and MCAD, having the ability to then run thermal simulations or even CAM on the PCB. So really quickly and easy, we can then go ahead and have all of that as a complete integrated ECAD to MCAD environment directly within Fusion itself. And the other preview that was released within that August 8th release is the browser version of Fusion. So from here, we've been pushing the boundaries for a few years now with hardware, so not having to just run on a Windows machine. We can also run Fusion on a Mac. but we now have the ability to run within the browser. Now it's limited functionality, it sketches, extrudes, cuts, but it gives you the ability, if you're with a client or you want to make some very small changes to a design, to quickly and easily do that directly within a browser. You can launch any of your designs from A360 or Fusion Team directly within the browser itself. It's just a click on the actual on a point within the environment itself, which I'll show you, and you can start to generate a design or start to make some changes to a design or a very quick concept directly within the browser. Now, when you're ready to, you can then start to look at adjusting features, but also pushing this design back into your desktop. So if you're out on and you only have something like a Chromebook or something, you can go ahead and make those modifications within the browser. But then you can also, once you're back at your desk, push that design from browser directly into a desktop application as well, or desktop Fusion. So it gives you the ability and the flexibility to use Fusion wherever you are. Again, coming back to that point initially where I said accessibility anywhere. As you can see at the top, pick a design, edit in browser or desktop within the actual web interface. So a very quick and easy way of actually going ahead and looking at a different way of designing within Fusion. So again, those are the couple of previews that were released within the August 8th release. So again, I implore you guys to go ahead and start to look at those and use those. You can activate them from the Preferences tab in the top right hand corner of Fusion under your name or under your user. Hit Preferences and then you'll see at the end of it previews, and then you'll see the previews tab just there. So it gives you the ability to go ahead and start to look at those as well. So again, those are from customer enhancement requests. So again, pop up to Idea Station on Fusion itself, and we can quickly and easily start to look at implementing the ones that we need. So again, we implore you guys to go ahead and give us an idea on what you want from Fusion itself. And with that, we actually publish our roadmap live. So you guys can see what we're working on in development for this year. So you can start to see what we're going to go ahead and focus our efforts on. So there's a lot on 2D drawings. There's some stuff on ECAD, MCAD, which we've released. Stuff on sheet metal and simulation. And if there are ideas that you guys have, you can go to fusion360.com and under community, you'll see Idea Station. Raise an idea. Every idea is taken seriously, so you guys can go ahead and start to see those. So if you want to find out anything more about Fusion 360, you can visit our website at autodesk.com/fusion. And from there, we've got a whole host of material, but we're also on social media and bits and pieces as well. So thank you guys for your attention today, and thank you for joining this webinar on sheet metal. It was a very quick overview of the new functionality within Fusion 360. And by all means, enjoy your day and enjoy the rest of your week. Thank you, everyone.